Mustard gas was one of the most used weapons in World War I. Nearly a century later, Mancal and his team in China have discovered a new scam that shows superior sulfur mustard simulated degradation efficiency and achieve a half-lifetime of 1.5 minutes, which needed only 4 minutes for the conversion of 98% CEES into the non-toxic oxidation product of CEESO under an O2 atmosphere. Non-toxic CEESO2 was detected throughout the detoxification process even after a long reaction period of 2 hours. For practical application, the reaction was tested under air atmosphere where it fully decomposed CEES into CEESO within 14 minutes with a half-lifetime of 6 minutes. This new scam offers a new way to detoxify mustard gas and provide a platform for further advancement in the exploration of novel photocatalysts.
Osmolytes are organic solutes that are generated by cells of diverse life forms in response to osmotic stress. Cold stress generates osmolytes as well, coining these as cryoprotectants, although little is known with respect to how this mechanism works. Scientists from the Israel Institute of Technology attempted to gain insight to this phenomenon. They developed an experiment using a silica colloid and oxidized silicone wafer in solution with varying concentrations of proline and electrolytes at variable temperatures. Via usage of an atomic force microscope, the electrostatic repulsion between the two surfaces was measured. Accumulation of cations near the silica surfaces increased at cooler temperatures. In a biological setting, this cation accumulation would destabilize proteins and inhibit enzymes. However, proline, a known osmolyte, desorbs the cations from negatively charged surfaces, which would restore normal biological function. Govern and Obstone's findings offer insight with respect to why osmolytes are accumulated in response to cold stress and thus behave as cryoprotectants.
If you have ever built something on your own, you understand the struggle of measuring and making sure everything will fit together correctly. On the nano level, Gangfen Chen and other researchers found a way to not only assemble uniform hexagonal platelets, which are minuscule six-sided crystals, but precisely control the dimensions of said platelets, no measurements required. Due to the organic structure of TPP molecules, several polymers are able to interlock and form three-dimensional structures, much like connecting Legos together. Only instead of pushing the blocks together, the polymer TPP mixture simply needs to be heated up, and possibly more importantly, if you step on these, you wouldn't even know it. Then, by changing the concentration, or the polymer to TPP ratio, they found that they could control the dimensions of the platelets, and after several tests at different concentrations, the researchers were able to change the platelet heights by 200 nanometers and their widths by 1.5 micrometers, all without measurements, just by changing concentrations and heating up the mixture.
Hepatocellular carcinoma is the most common type of primary liver cancer. Single-chain cationic polymer dots were formed by the rapid nanophase separation between glycol and water. These P dots have a 3.6 nanometer diameter and have extreme brightness and stability. The small size of these P dots provides great penetration into cellular compartments. Applying the P dots to the HCC cells in healthy cells shows that these P dots can selectively discriminate the cancer cells by their luminescent capabilities. The selective translocation of these P dots into the nuclei of cancer cells has shown the ability for discrimination of HCC in healthy liver cells. It was found that P dots stay in the nuclei of the HCC cells in the cytoplasm of the healthy adult liver epithelial cells, making simplified determination of borders at the cellular level. They concluded that P dots may be used for accurately and precisely determining surgical borders in cancerous tissue, providing the ability for surgeons to separate out cancerous tissue due to the fluorescent brightness of these polymer dots.
What if we had a vaccine for bacterial infections such as E. coli? Researchers at the Scripps Research Institute recently developed a method to evolve E. coli to be dependent on the non-canonical amino acid parabenzoyl phenylalanine, or PBZF, which is not one of the amino acids found in the human body. Amino acid 273 in the protein-protein interface of the sliding clamp used in translation was mutated to be dependent upon PBZF for survival. Variants 1 and 5 were allowed to grow in both permissive and non-permissive media. Both variants showed growth that was dependent on PBZF in the permissive media with no growth in the non-permissive media. Because a hydrogen bond is able to form between the PBZF residue and one of the surrounding amino acid residues in variant 5, escapees were unable to be detected. The researchers are hopeful that this strategy can be used to develop other strains of bacteria that are dependent on non-canonical amino acids for their survival. These bacteria could then be used to develop live vaccines for infections that pose risks to hospitalized patients or those with health risks.
Perovskites are molecules that have the general form ABX3, where A, B, and X are various atoms respectively. Some years ago, perovskites were synthesized using nanoparticles such as quantum dots and nanowires. These perovskite crystals can be grouped together to form structures called nanosheets. This article looks at a new way to arrange these sheets in order to yield better stability and slightly increased emission wavelength. In the right conditions, the nanosheets will arrange themselves into layer blocks. This arrangement is known as the Ruddleston-Popper phase. Over time, the individual nanosheets will attach to each other and form the layers, which can reach a thickness of about 25 individual nanosheets, or about 50 nanometers. As mentioned before, one of the desirable properties of this arrangement is its greater emission wavelength. A single nanosheet has an emission of about 431 nanometers, and the Ruddleston-Popper arrangement shows an emission peak at 440 nanometers.
Rheumatoid arthritis, an incurable autoimmune disease characterized by chronic inflammation, leads to cartilage and bone destruction, long-term pain, and irreversible joint deformity. Due to drug toxicities and drug resistance, only a small amount of people benefit from pharmaceuticals, as there is a lack of drugs to treat this. Maybe not for long. A new compound, isolated from the traditional Chinese medicinal plant Cledion brevipetiolatum, has promising anti-inflammatory effects. Research done by Min Zhao and coworkers has shown that this compound, referred to as 9, has inhibitory effects toward nitric oxide. It also has shown that 9 suppresses NF-kappa B, showing the potential for 9 to be developed into a lead compound to treat rheumatoid arthritis. The compound was used to treat mice with collagen-induced arthritis. In the treatment group, arthritis progression was significantly suppressed after treatment for 22 days. Compound 9 inhibited joint swelling and edema formation in the mice, making it a front runner for relieving rheumatoid arthritis.
We all have a general sense of what a fingerprint is, but what if we could analyze the unique distinctions of each fingerprint using a combination of chemicals to pinpoint those characteristics? This study reports the combined use of enzyme-linked immunoassay and enhanced chemoluminescence for latent fingerprint visualization and specific substance detection. The principal reaction in this study was carried out by having different types of fingerprints react with an initial antibody, followed up by a second antibody and horseradish peroxidase. The combination of these reactions with the washing of a buffer containing luminol and hydrogen peroxide causing a fluorescent reaction illuminating the fingerprint. These are the chemoluminescent images of a human immunoglobulin fingerprint using the correct exposure settings. Each image captured the fluorescing fingerprint. The fluorescing of the latent fingerprint allows for identification of the minutiae, which are characteristically unique to each individual. Noted here are the match scores of minutiae after an hour of chemoluminescence in Figure 2, showing little differences in the match score. This indicates that even though the intensity of the latent fingerprint decreases, the ability to detect minutiae with this technique depreciates slowly, providing a useful technique to identify an individual from fingerprints made of different substances.
The grapevine red blotch virus, GRBV, causes an economic loss in the range of 2,231 to 68,548 per hectare every year. Current diagnostic methods for the GRBV do not provide sufficient detection. This August, Yang Li and coworkers have developed a plasmonic CRISPR-Cas12a assay via integration of target-induced CRISPR single-stranded DNA activation and color transition mediated by plasmonic gold nanoparticles. Detection of the virus can be done in the field, and a positive indication will turn the sample red. This is due to the presence of the viral marker. S will be degraded by Cas12a, and the gold nanoparticles will not be able to link, causing the solution to remain red. If there is no viral infection, the solution will transition to blue. This color transition takes 5 to 15 minutes.
The amount of carbon dioxide released into the atmosphere by the burning of fossil fuels is projected to hit 37 billion tons by the end of 2019. The resource is depleting rapidly, and at the rate in which we currently burn, the resource will be completely expended by 2060, roughly 40 years from now. Research has been presented to better support the idea of renewable energy, one of those being hydrogen evolution reaction. By increasing the catalytic activity and stability of the electrodes by doping the normal platinum electrodes with nickel and encasing the new nickel platinum with nickel sulfide, they are able to decrease the measurements of the overpotential and current density to the lowest to date. This technique managed to also increase the life of the electrodes from 30 hours to 8 days. By providing a bifunctional pathway from the designed electrode, it provides efficient promoters for water dissociation to increase hydrogen evolution and essentially give the world an alternative source of energy, allowing for a safe environment for generations to come.
The detection of explosives in real time is an everyday issue we deal with to try and combat against terrorism and environmental pollution. Scientists in India and Taiwan have recently discovered a new pyrene-tethered, pyridine-based fluorescent probe known as TL-18 to use as a chemosensor for minuscule detection of nitroexplosives. To find which compounds this probe was particularly selective for, they ran fluorescence response tests and added small amounts of various nitro compounds to TL-18. From the figure, it can be seen that TL-18 has a strong selectivity towards detecting picric acid. The fluorescence detection was plotted and the limit of detection was calculated, and they found a limit of detection of up to 63 nanomolar, which by comparison is far better than any other probes currently in use. To facilitate real-time detection of picric acid, they have tested it using a portable fluorimeter, which includes a smartphone. This probe and chemofluorescent sensor proved to be efficient enough to be used in future applications of the detection of nitroexplosives.
Scientists in China have discovered a new use for yeast besides alcohol fermentation. Yeast can also be modified to produce lycopene, the nutritious red pigment that is commonly extracted from tomatoes and has proven to have anti-aging effects and serve in cancer prevention. Scientists have taken the yeast Saccharomyces cerevisiae, or standard baking yeast, which in its natural form is unable to synthesize lycopene, and created a new metabolic pathway in order to optimally combine gene expression enzymes CRT B, E, and I and incorporate glucose instead of galactose to control gene expression. The experiments required the researchers to test numerous strains and determine which had the highest lycopene production under the new conditions. After final tests, strain BS106 in red showed the greatest potential for lycopene overproduction, and the eventual lycopene yield was 3.28 grams per liter. This is the highest yield to date, and the positive results indicate that in the future we will see an increase in lycopene supplements produced from baking yeasts, as well as a decrease in tomato food waste.
Around the world, malaria annually infects over 200 million people, and almost half of the world's population is at risk for this deadly disease. This year, scientists in Florida and Australia collaborated to investigate a compound that could be used to inhibit the growth of Plasmodium falciparum, a parasite that causes the deadliest form of malaria. This compound, freomoramid, was extracted from an Antarctic sea sponge. As seen in Figure 1, freomoramid showed 90% inhibition of Plasmodium falciparum liver stage development, while also having no toxic effects on primary human hepatocytes at 5 micrograms per milliliter. As seen in this graph, freomoramid is similar in action and safety to the anti-malarial drug primaquine, labeled PQ. Considering the emerging drug resistance of blood stage infection of Plasmodium falciparum, new drugs that can inhibit a different phase of growth are vital to controlling this deadly worldwide disease.
As of now, there are no pharmaceutical options for treating meth addiction or to reverse the effects of an overdose. The demand for such a treatment caught the attention of Dr. Olson and her team at the Scripps Research Institute and led to the development of an active vaccine containing a meth analog that could produce large amounts of high-affinity antibodies to neutralize the drug. The team began by adjusting a previously designed meth hapten to release low-specificity antibodies at high concentrations that resemble those found in users seeking a high. The data in Figure A show that more antibodies were produced over time, indicating the mounting of an immune response in the vaccinated mice. Higher levels of meth were also found in the blood as compared to the brain, as shown in Figure C, signifying that the vaccine effectively removed the drug from the blood. Similarly, the researchers noticed that the vaccinated mice showed little or no evidence of physical symptoms, or tweaking, as compared to the control group. Lastly, the survival rates of the mice were observed after giving a lethal dose. The vaccinated mice had an 83.3% survival rate after 48 hours, while the unvaccinated mice had a 20% survival rate, as shown in Figure D.